Good morning, good evening, good afternoon, depending on where you are. This is Santosh Shiva. I head partnerships at eInfochips, an Arrow company. At the outset, I want to welcome all of you to our webinar, AI-powered vision solutions for tomorrow's enterprises. This webinar is being brought to you by eInfochips in collaboration with NVIDIA. These are extraordinary times, and we really thank you for taking the time out and attending this webinar. So why this webinar? It's because we are seeing an explosion in visual data combined with nonlinear increase in power on the edge, compute power on the edge. And to top it all, there is omnipresence of cloud. In this session, we will be exploring how companies can leverage this explosion in vision-based data to construct AI solutions for some key business problems. The webinar itself is going to be for about 45 minutes in total. We will spend the latter part of the session on taking questions. Before we dive into the presentation, I want to walk you through the outline of the webinar this morning. Basically, what we want to spend time on three basic core pillars of vision-based AI: the why, the what in terms of what are the use cases, and the how. So we'll spend time on trends and industry use cases, application workflow methodologies, and of course, also talk a little bit about what eInfochips and NVIDIA bring together as a value proposition. At this point, I want to also introduce our speakers in this session. We have two extraordinary gentlemen who are here to lead us with the session. Barry Mullins, who is the Director of Technical Marketing for Embedded and Autonomous Machines at NVIDIA, and he's been at this for a couple of decades. He has been engaged in developing, launching, and growing innovative and leading-edge embedded products. And I also have with me Gurpreet Singh, who is the Solution Architect for Product Engineering Services at eInfochips, where he works with customers very closely to develop AI ML on the edge using Jetson platforms. So I welcome both of them to the session. And a quick word about eInfochips itself. So eInfochips is a leader in product engineering services. And today we lead developing edge to cloud solutions for our customers. We've been in business for 25 plus years. 80% of our revenue comes from connected devices and cloud-based services. We have close to 500 plus products that we've developed on for our customers, which are deployed today in the market. And we are about 2,000 employees. And now we're also a part of Arrow Electronics. We are a part of the Arrow Electronics Engineering Services arm. So that's a quick word about eInfochips. And with that, I want to hand it over to Barry Mullins and go forward with the session. Barry, over to you.
Hey, thank you very much, Santosh and eInfochips for hosting this webinar and the introduction today. NVIDIA is a computing platform company at the intersection of graphics, high-performance computing, and AI. And NVIDIA pioneered accelerated computing to solve problems that normal computers cannot solve. And for edge AI systems, NVIDIA brings together graphics for simulation, rendering, and perception with high-performance compute to fuse and process sensor data with AI, then to provide insights and analytics. You'll hear a lot more about how we do that throughout this presentation. And in the next slide, you can see many of the different applications and companies that have taken advantage of NVIDIA's Jetson Edge AI accelerated compute platforms. And these solutions are not only helping our industries to be more productive, but also our world to be safer, healthier, and happier. And given the current situation, I just want to highlight a few items here. One would be Nanopore, who use our Jetson TX2 to perform DNA sequence in the field. Also delivery robot companies like JDX that use our Jetson AGX Xavier to provide supplies in areas of quarantine. And of course, service robots that are lending a hand to patients and doctors in hospitals. And then we also have several customers that are deploying systems to detect face masks, measure social distance, and doing contact tracing in hospitals and medical facilities. And it's great to see our customers doing such valuable work and contributing to society. Now I will hand the presentation over to Gurpreet, who will walk you through some of the challenges and solutions from the eInfochips perspective, and I'll come back and talk to you later on.
Thank you so much, Barry. So let's put things in context. Some estimates put number of camera sensors out in the wild at around 1 billion. They are everywhere on the street, in shopping malls, airports, and even our mobile phones. With an estimate about 30 billion images are being generated every second, translating to about 2,500 petabytes of data, and that is video data. Unfortunately, 90% of the video goes unreviewed and we lose valuable hidden trends and subsequently business opportunities. Thanks to artificial intelligence, machine learning, and deep learning technologies, we can gain essential insights from data in the form of objects and patterns once we classify and segment the data. In the next slide, we'll talk about the application workflows. So the AI ML vision workflow starts when the video data is captured from one or more camera sensors. NVIDIA's Jetson family Nano TX2, Xavier NX, and AGX Xavier have various interfaces such as USB and CSIs, where these sensors can be connected and even supports Ethernet to receive video streams. Generally, camera sensors require tuning of the camera ISP pipeline with the algorithms such as autofocus, auto exposure, auto white balance, popularly 3A algorithms. InfoChips has an in-house lab for camera sensor tuning as well. Once video is captured, it has to be pre-processed before it can be used as input to the mode. Such pre-processing could include transformations such as cropping or scale or color conversion. The training model can now use this data to detect, classify, segment, or pre-detect based on the use case requirement. NVIDIA's Jetson DeepStream SDK have support for GStreamer plugins that provide hardware acceleration such as Decode or GPU. It also has Transfer Learning Toolkit that allows us to use pre-trained AI models and fine-tune them as needed. NVIDIA's TensorRT helps to optimize the inference and runtime, which leads to low latency. That's critical for applications. The trained model uses GPU and DLA for acceleration and extracts valuable insights that can be transferred as metadata to the cloud or to the data center for further processing. With NVIDIA's Kubernetes and DGX servers, we can deploy GPU-accelerated deep learning training or inference applications to heterogeneous GPU clusters at scale seamlessly. So analytics built on top of various AI models can run smoothly over GPU clusters and gives us visualization of hidden insights that can power the business. Let's talk about some challenges as well in the next slide. There are certain challenges that industries face when they start thinking about using AI. Look at the enterprise maturity, create accurate AIs, and so on. So let's evaluate those. The business needs and use case for AI vision should tie in with the strategic vision that your firm has and should be one that can help to accelerate your growth. It requires people who can understand the use case and build, train, deploy the AI model as per your needs. The challenge is that the AI model has to be accurate and must give accurate results in a specific time frames. This depends on what kind of data is available, what transformations are done on the data, and identifying the type of problems when it comes up. Is it a classification problem or one of the detection or segmentation? Does the data have enough variation to make model robust, such as occlusion, lighting conditions, and so on? Finally, where the model has to be deployed at edge, does the hardware have the required interfaces to support various sensors? Is the hardware with GPU fast enough? Will the model run at required speed and memory consumption with processor not being overloaded? Does the platform have various frameworks, SDKs, which helps to deploy the model with hardware acceleration? How can we connect the hardware with the cloud for transforming the metadata and visualization on the cloud? These are some of the most important questions that need to be answered before embarking on a journey to adopt and deploy AI vision. Over the next few slides, we'll try and answer some of these questions when we talk about use cases. Let's talk about a couple of use cases here. Various industries have adopted AI vision as the next wave of change. If we talk about smart cities, government across the world are looking for ways to increase the quality of life and make cities safer and smarter. Some of the ways by which we can achieve these goals are by having smart lighting to save electricity and reduce carbon footprints, by having smart traffic management by reducing accidents, unclogging the highways, and increasing pedestrian safety, by smart parking to reduce the fuel wastage, and critical in a COVID-19 situation to maintain social distancing in public. Moving on to retail analytics, today's retail stores are being transformed with intelligent video analytics, IVA, from customer experience to business optimizations, from store management to security and surveillance. It has adopted to be more consumer focused and has led to increased profits due to a reduction in thefts. IVA is used to understand store traffic data such as the footfall numbers, heat map analysis to see where the customers spend more time. It's even used to manage the queue during checkout and make it seamless and hassle-free by having smart shopping carts and scaling or adjusting the billing counters dynamically. So let's look at a few case studies in the next slide. A smart city also means a cleaner city that cares about organic and non-organic waste. Generally, garbage consists of many different things such as cardboard, styrofoam, metal scrap, and these should be segregated before the garbage reaches the recycling plant. A camera mounted on a garbage container captures images, and these images are analyzed on an NVIDIA Tesla T4 server. These were various challenges when we observed the captured images such as deformed objects, object occlusion, irregular shape and size of the objects, variations in ambient lights, densely packed objects, and so on and so forth. So the image had to be pre-processed using various techniques such as adaptive histogram equalization and sharpening to remove the noise. Then the annotation of the image was required to identify objects that were clear. We evaluated various object detectors such as ResNet, YOLO, and SST, but we found RetinaNet to be best suited to our need, as it supports hierarchical feature pyramid network and focal loss technique for dense object detection. Various images were used to train and test the model using AWS and Transfer Learning Toolkit. For inferencing, NVIDIA's TensorRT helped to deploy the model on the server using Tesla T4. Initially, the model consumed about 430 megabytes of space with 93% accuracy. I'm sure you'll guess that that's a lot. The customer also wanted optimize of space and to understand the impact of this. So with pruning, the model was streamed down, and now it consumes only 4.2 megabytes, and the accuracy is at 88%. We are currently working to increase the accuracy, capturing more relevant images, and also exploring if we can deploy the edge using Jetson Xavier. The next slide talks about the topology that is being used in order to do the contamination detection in terms of the input models, the DL inference algorithm, and DL framework that was being used. Let's look at some more caselets in the next slide. The smart traffic is a backbone of any smart city. There are more than 1 billion vehicles on the road, and traffic management can impact both the economy and the environment. It requires 24/7 surveillance to check if a driver is following rules properly, are there enough parking slots available at a given time, and etc., etc. Generally, the video streams are captured and sent to cloud where they are analyzed and then decisions are made. Sending 1080p 30 streams is data and bandwidth intensive, and thus we developed a proof of concept where decisions are taken at the edge instead. We achieved this by developing a deep learning based solution on NVIDIA Jetson platforms, making the traffic detection efficient in real time. The solution supports features like vehicle anomaly detection, vehicle parking spot detection, vehicle counting, and wrong turn detection, among the others. Object detectors such as YOLO V3, YOLO V3 Tiny, and SST Inceptions were analyzed. The model were trained and tested on AWS with videos captured on various cross sections of the city, YouTube videos for various classes, And these models were deployed on Jetson Nano and Xavier platform by using TensorRT and the Transfer Learning Toolkit. Let's talk about some salient features in the next slide. The GStreamer pipeline is similar to what we discussed a few slides back in more generic form. We have the option of capturing images using a camera sensor or by reading the file from a location. The video is decoded by using NVIDIA's NVDEC plugin that uses hardware video decoder as an accelerator. Decoded YUV frames are pre-processed to scale or crop and fed to the model for detection or classification of objects such as car or bike. We have also developed a GStreamer plugin to take actions and decisions on the output of the model, and one can apply various business logics to it, such that to issue a ticket if there is any wrong U-turn being taken by the driver. We can observe the performance differences on pre-trained model and our trained model, such as for YOLO 3. It increases from 55 to 90 mean average precision using model pruning and TensorRT. Parameters for accuracy calculations for object detection models are true positive, false negative, false positive, true negative, and intersection of union of every object. The performance improvement involves various phases in which we do a step-by-step analysis, such as, do we require more data for model accuracy? Which algorithm network model framework suits our needs? What is the underlying hardware? What are the available tools to improve the model accuracy and speed on hardware? These are top-level questions that help us determine the right path for using AI vision. Let's look at some of these use cases in the next few slides. So on the left, the model calculates the number of vehicles crossing a region of interest in up and down direction. The ROI is highlighted in a green color box and cars are detected in a blue box. As the cars cross the ROI, the counter increments accordingly. Whereas on the right, the model calculates number of parking slots available. Filled slots with the car are detected in blue, and the ones which are vacant are detected in green. In a subsequent slide, we talk about some of the additional use cases we talked earlier. So on the left, the model checks if there is any vehicle that has made a sudden stop from 80 or 90 miles per hour and detects it as an anomaly. On the right, the model checks if a vehicle has made a wrong U-turn and then detects it as a wrong turn. Some of the important KPIs that I want to run you with are algorithm accuracies, performance and execution speed, complexity of models, cost versus benefit, and the underlying parameters that we look at are ease of implementations. How do you partition the implementation server versus edge? That's always a debate. Time to market the solution and incorporation of security. With that, I would like to hand over to Barry for other alignment.
Thanks, Gurpreet, for that insightful data and some interesting use cases. As I mentioned earlier, over the last few years, we've seen huge growth in the development of Edge AI. And we at NVIDIA have over 500,000 unique developers and 3,000 customers actively designing and programming for Jetson-based systems. Here you can see the broad number and types of applications that these developers and customers are working on. And Jetson is a software-defined platform that leverages NVIDIA's accelerated compute architecture combined with the CUDA-X accelerated software stack. This then combined with many of the other application-specific SDKs and the open source community code that's available allows these customers to develop and deploy these applications. And for this reason, Jetson being a software-defined platform, it's ideally positioned and it's being adopted for all Edge AI systems in the delivery space, retail, many different mobile robot applications, agricultural applications, logistics, manufacturing, healthcare, optical inspection across multiple industries, and much more. But that said, designing Edge AI systems is not without its own challenges. And Gurpreet mentioned some of those challenges earlier, and I'm just going to take a little bit of a deeper dive into some of the three major challenges that we hear about from our customers. And the first one here is building systems that can run multiple diverse and complex neural networks in parallel. These neural networks will be updated regularly based on the new data and new models that come available. So it's critical for systems not only support today's models, but models of the future. And these models need to run both, detection, classification, and other capabilities in parallel or in series at the same time on the same system. And the second challenge customers talk about is selecting a platform that includes and accelerates the critical parts of the system to meet real-time edge AI application needs. And many of these systems integrate and fuse data from multiple sensors that is then processed by the deep learning algorithms. And finally, that data is used to take actions and is stored or shared with external systems. And they're looking to accelerate all of those steps in the process, not just the AI inference piece. The third and final challenge that we hear a lot about is the ability to develop, deploy, and manage edge AI devices at scale. The nature of AI and neural networks and the models that they create is that they require regular updates based on new data, new use cases, and this continuous change is driving the need for embedded systems to be software defined. It's also driving the need to be able to manage a large network of embedded systems over large periods of time and to manage the software and each of those systems in that network. And on the next three slides, I'll go a little bit deeper to show you how NVIDIA provides the computing platform to run complex neural nets and how Jetson and Jetpack accelerate the full software stack and how we're solving some of these software management and deployment at scale issues. And here you can see the Jetpack software stack and software developer kit that enables Jetson as a software-defined platform. And it enables it to accelerate all aspects of the solution from sensors to inference to outputs. Each of the Jetson modules uses the same software stack for development and deployment of AI, making it extremely scalable to use. Each module is capable of running a full desktop Linux system that is out of the box used to start development. And this can be optimized for application deployment. And Jetpack also provides developers access to the full suite of CUDA accelerated software from NVIDIA. And this CUDA-X software includes acceleration for deep learning, multimedia, computer vision, accelerated computing, and a host of other sensors that you want to integrate in the system. And that CUDA-X software will take advantage of all of the underlying Jetson module capabilities to deliver, a power-efficient performance in that edge-based system. Now, if you require custom design or optimization, Jetpack does include a suite of Nsight developer tools that allow developers to profile their code, analyze and optimize their code across the GPUs and CPUs and other hardware engines that are built on Jetson. It also leverages the other software developer kits from NVIDIA, including the Transfer Learning Toolkit, which allows you to quickly develop and deploy or develop neural networks based on your data, and TensorRT that allows you to optimize those neural networks for deployment on an edge platform. And for application-specific designs, you can take advantage of DeepStream for intelligent video analytics or Isaac for robotics, and these all work with the Jetpack software and with Jetson. And this broad suite of software allows Jetson to run these multiple complex networks in parallel and accelerate the various different phases of the process. Now, as a software-defined platform, Jetson supports, cloud-native capabilities and enabling edge AI systems to manage and upgrade software using containers and microservices. And this is on the next slide. And this makes software maintenance, upgrades, and deployment to millions of systems much, much easier and more manageable. And Jetson does that by supporting a Docker engine that's required to build and ship and run these containers. And that Docker container is a lightweight standalone executable package that includes everything that's needed to run that application. And you can have multiple containers running on the same Docker engine in a single Jetson. And with the use of those multiple containers, that makes Jetson a hugely scalable product. It also means it can be managed from a cloud perspective, where you can push different containers to different products when required. And as an Edge AI system, this is going to drive the next generation of embedded systems, how they're architected, how they're deployed, and how they're managed. And of course, all of this is done on the hardware platforms shown in this next slide, which is basically the Jetson family that we've developed as a platform, and it leverages the exact same GPU architecture that's used to train AI to perform inference and that, but we've done it on a small, power-efficient platform. And this family includes modules that run from a half a teraflop here on the left in Nano for under 5 watts, up to 32 TOPS on the right in Jetson AGX Xavier for 30 watts. And these Jetson modules, because of their software defined and they take advantage of the Jetpack software stack, each module that comes with its own GPUs or CPUs, memory, IO, and sensor interfaces, combined with that software, really makes it easier to deploy and develop that AI system. From a hardware perspective, you can see that Nano on the left, the Jetson Nano, and the Jetson AGX Xavier, which is just right of the center, are smaller than a credit card size. And they're also pin compatible and offer different performance capabilities. So customers that want to scale from a low-end product to a mid-range product or high performance product, they can use the same components, the same software, and interchange those. You can also see that on the right-hand side here, we have our Jetson AGX Xavier that delivers our highest performance and actually allows you to develop and deploy fully autonomous systems for under 30 watts. And that has been used in some of the examples that I referred to earlier. So I'd like to thank you guys for your time today, and I'm now going to hand it back to Gurpreet, and I'll talk to you and answer any questions that come up shortly.
Thanks, Barry. So I think important to understand what's eInfochips' value proposition here. For a couple of years, we have been working and exploring NVIDIA Jetson platforms, great SDKs, frameworks for AI and machine learning activities. And now, since we are a preferred partner, we bring a lot of capabilities and are committed to serve our customers. Starting with hardware, we have about over 15 plus years of experience in designing different system on modules, carrier boards, customer product designs, which encompass the full product life cycle, including schematic layouts, signal integrity, spring ups, validation, supporting customizing middlewares and applications. Sensors are the eyes and ears of vision-based systems, and a camera is one of the most complex sensors on which we have developed expertise. For many years now, we have enabled sensors from various OEMs, and we have helped customers in selecting different camera sensors and develop and integrate them in their solutions based on resolutions, frame rates, formats, interfaces like MIPI, CSI, USBs, types which are DPHIs and CPHIs, different type of cameras having PTZ, IR cut filters, and developed drivers, integrated them, tuned these drivers, and supported AI ML algorithms. We also have an in-house camera sensor tuning lab with required tools and ISO charts to tune the ISPs. And to add to the last mile in the value chain, we do provide cloud services to enable data analytics on the product. The value proposition is that we understand customer challenges in depth, help customer to select appropriate models, sensors, neural network based on past learnings, combining that with strong pool of trained resources who can help to do a rapid proof of concept as per the use case requirements. So with that, we move to Q&A. I'll hand it over to Santosh.
Gurpreet and Barry, thank you so much. I think that was a very enlightening and interesting session. I hope the audience found it interesting. There are a few questions that I'm seeing on the box. So here's the first one from Kirtika Devi. The question is, Can you repeat the method used to segregate the image objects in the garbage? And that question is for you, Gurpreet.
Sure, Santosh. So it was the adaptive histogram equalization and sharpening to remove the noise as a first step as a pre-processing. And then the annotation of the images were required to identify the objects were becoming clear. So we evaluated and used RetinaNet as a network in order to do that, because it supports hierarchical feature pyramid network and focal loss technique for dense object detections.
Thank you. I have another question from Samriddhi Singh. The question, and Barry, I'm going to point this to you. This is, how can we apply AI technology to the engineering, procurement, and the construction sector? If you can take that, Barry.
Sure. That's an interesting question, and it's a pretty broad sector. I'm just going to focus on edge-based applications because that's where my expertise is, and I know a lot of my colleagues in NVIDIA could give you applications that might apply to some of the logistics and supply chain items that go with that. But from an edge-based perspective, we see a lot of those construction equipment companies incorporating vision sensors and some form of cameras into their systems to do a lot of the object detection in the environments that they're in. And in some cases, it's for autonomy within that product, but generally it is used in conjunction with the safety and the drivers or the users of that equipment to kind of enhance their ability to detect or to identify what's happening in the region. And you may or may not have picked up on one of the slides earlier on, but we did have a picture there with Komatsu, who are using some of the cameras to map out a construction site and identify people on that construction site and where they are relative to the equipment, make sure that they're safe. We have other customers then that are using it to detect what those people are wearing to make sure that the site is safety compliant and that. And you may have heard of other products that are out there from a construction perspective that are where robots are beginning to come in and work with people to make the jobs more efficient or to take on some of the very manual tasks. One of the ones I saw most recently was a bricklaying solution where they do a lot of object detection and classification, and then they line up all the bricks and they put them down and they're able to place them. So some of the heavy lifting and physical work is taken over and automated to make things more efficient. So there's just some examples of what we're seeing out there.
All right, a few more questions here. So this question, is there a certification process? And Barry, I'll point that to you. I think it probably is a question about, is there a certification around the NVIDIA platforms? I'm assuming that's the question. Barry, would you like to take that?
Yeah, sure. So what NVIDIA provides in order to get people educated and up to speed and quote certified, we do give out certificates at the end of our trainings, and that is many different courses from what we call our Deep Learning Institute. That's a DLI. And as you take those, they cover various different aspects of deep learning and AI, all the way from developing a model based on data that you've got. How do you annotate the data and build that data set into something that you can then develop a model and train a model, all the way through to how do I convert that model into something I would deploy on a piece of hardware. We have all that training, and some of that training is application or market specific, and we provide certification on all of that. And there are 2 courses that are free courses for anybody who's interested. One is on the Jetson Nano. There's a free Deep Learning Institute course there. It takes about 8 hours. It's a great starting point for somebody who wants to understand about how do I develop a model and deploy it on the edge. It goes through some of those key steps and key learning there. And then we have another free one that we do on our DeepStream SDK that helps you to build that whole video pipeline and take all of the sensor data in and then process it using an AI algorithm and tuning that algorithm and then being able to display that and detect things at the other end. So we do certification. There are many other courses out there through other organizations, and we work very closely with a lot of the third level educational facilities across the world to build some of the content into their instruction and everything else. So people coming out of universities and that will have a good foundation and a good basis of AI.
Thanks, Barry. The next question is from Richard Smith. And the question is, how can one improve AI model accuracy? What are the best practices? I'll point that to you, Gurpreet. Can you take that?
Sure, Santosh. Good question, great question. So there are essentially multiple techniques that you can use. The first important is to have a clarity on the data classification and labeling. That's one of the most important. Data format uniformity is the second one, which you can identify from the data sets. CNN selection is very critical in terms of identifying the right CNN that you use. Selection of data training tools, which kind of train the model and improve the accuracy, is equally important. And selection of data models. But then beyond that, it's also important from an edge perspective that you have a right set of hardware and interfaces available in order to be able to improve these models.
Thanks, Gurpreet. There's a follow-on question from Ricardo McCowan, and he's asking, what is a suitable model of a learning model? Is it supervised or unsupervised? What is your view on that? Again, Gurpreet, I point that to you.
So I think that's a very subjective way of looking at it. Depending on the application use case, you can choose either of them. It really depends on what sort of application and criticality that application has, and accordingly that can be chosen. I think we can provide and have a discussion separately offline on that. Yeah.
Thank you. A question here from Vasant is AGX, Xavier, CUDA-X used in defense applications. Can you talk about a few examples? Barry, I'll point that to you.
I can say yes, that those organizations have elected to use Jetson and the software stack that comes with that. As for some of the applications, I don't want to be too specific because they put them in various different products that they build, and they're doing a lot of high performance compute in those areas, whether it's a radar application or a flight controller. Sometimes it's display capabilities that they take in the video and they process it and then they put it up on display. But it is used across multiple different applications within that space. And I'm thinking there that the question is also related to some of the stringent and rigid processes that those organizations use, and we work closely with some of them to make sure that we're able to meet their requirements and deliver what they need.
Okay, thank you, Barry. There's a question here about, and please excuse me, I'm going to skip names here in the interest of time. There's a question around, please share your thoughts on what kind of vision accelerators are present in NVIDIA Edge platforms. And Barry, do you want to take that?
Yeah, so from a vision acceleration perspective, if you look at what we've done from starting at the inputs to the physical system on a Jetson, we have built in MIPI and CSI interfaces directly into the system. So many of our customers and applications now take MIPI and CSI cameras and they bring them straight into the actual module that we supply. Then they process that through the vision pipeline that we have there. So we have that full vision pipeline capability at the front end, which includes an ISP and then vision processing to manage and change those images, whether it's to dewarp them or to denoise them and to do white balancing and that, so that the image is better for processing when it gets to the back end in the AI kind of processing area. And then, of course, we do have that GPU capability in there that is very, very good for a lot of image processing techniques. And we also have encoding and decoding from a compression perspective. So when you put up all of those pieces together, that's what we talk about for the additional engines from a video or image processing perspective. And then all the CUDA-X software on top of that calls the different engines, or you can choose, hey, I want to use this function to run it on the GPU, or I could use this function to run it on a different piece of hardware. So we do give you the same functions or capabilities to be able to pick and choose sometimes the different engines. I hope that answers that question.
Thank you, Barry. I think we are coming to close of the session. I'd like to request Gurpreet, any closing comments to the audience before we move on and close the session?
I think as E-InfoChips, we provide dedicated team for NVIDIA-based development activities with capabilities on different SDKs, rich SDKs that NVIDIA has to offer. We have a great team that works on it with a dedicated data scientist for AI model development to doing proof of concepts or transitioning those proof of concepts into an actual product use cases, whether it is for inventory management, automotive, smart infrastructure management, and so on. So a rich set of experience in terms of vision-based applications for different domains, and a partner of choice by NVIDIA to trust.
Thank you, Gurpreet. Barry, any closing comments before we close the session for the audience?
Nothing major other than we're seeing a great uptick in the use of AI and the innovative and creative solutions that people are putting out there. And many of those are built with our partners and our ecosystem. So we greatly appreciate E-InfoChips' contribution to that. So thank you guys for the work you do.
Thank you. And if you want to contact us, you can contact us at nvidia@einfochips.com. It's a email you can send us, and we'll get back to you on any questions that we couldn't answer today. Again, it's nvidia@einfochips.com. Thank you again for joining us today. Have a fantastic rest of the week and a great weekend, and hope to see you all soon. Bye-bye.
Thank you.